Hello everyone, welcome to Sankalp Learning Solution. Now we are going to discuss about the second PU Physics LBA KCET question answers related to the chapter number 10 Wave Optics. We will see the question answers one by one. Hello everyone, welcome to Sankalp Learning Solution. Let us start with question number 1. The surface that represents the locus of all points in a medium oscillating in the same phase is defined as option A ray, option B secondary wavelet, option C wavefront, and option D plane of oscillation. Here the question is where all points in a medium oscillating in a same phase. That is defined as what? First option ray. Ray is nothing but here this is the line perpendicular to the wavefront. Perpendicular to wavefronts, and this ray usually it represented as the direction of energy propagation. So this answer does not match. Option A wrong. Option B tells about secondary wavelet. Actually, this secondary wavelet is a small waves originating from points on a primary wavelets. This is originating from primary wavelets. So here secondary wavelet is also wrong. Means in secondary wavelet it is originating from a primary wavelets, and here all the points in a medium oscillating not in a same phase. So option B is also wrong. Option D tells about plane of oscillation. This is also wrong. Why? Because plane of oscillation is nothing but plane in which particle of a medium vibrate. Plane in which particle of a medium vibrate, that is called plane of vibration. So this is also wrong. This does not match with this question. So option C is the correct answer, that is wavefront. In wavefront, all points in a medium oscillating in a same phase. So this is called as wavefront. Option C is the correct answer. Thank you. Hello everyone, welcome to Sankalp Learning Solution. Let us see question number 2. When light undergoes refraction, if the ray bends towards the normal, the corpuscular model predicted that the speed of light in second medium would be option A less than the speed in the first medium, option B greater than the speed in the first medium, option C equal to the speed in the first medium, and option D proportional to the wavelength. Here just look at this image. This image shows about the refraction pattern. When light undergoes refraction, we know that what is the definition of refraction? Means bending of light in a second medium, that is called refraction. If the ray bend towards the normal, here this is the incident ray, it get bent towards the second medium. Corpuscular model predicted that. So this is the theory that is called corpuscular theory. According to this theory, when light enters a denser medium and bend towards the normal, this model, corpuscular model, assumes that the particles experiences an attractive force here, where that light bend towards the normal, the particles experience some attractive force. Due to this attractive force, that force get increases. The component of velocity is perpendicular to the surface here. So once this particle experiences some attractive force, this force increases the component of velocity, means here speed get increases. So the correct option is option B, greater than the speed in the first medium. Means this corpuscular model predicted that the speed of light in second medium would be greater than the speed in the first medium. The main reason is when this light get bent towards the normal, this model assumes that the particle experiences some attractive force. Due to this force, it get increases. The component of velocity is also increases. So option B is the correct answer. Thank you. Hello everyone. Welcome to Sankalp Learning Solution. Let us see question number 3. The firm establishment that light is a wave phenomenon followed the famous interference experiment performed by option A, Isaac Newton, option B, Christian Huygens, option C, Thomson Young, option D, James Clerk Maxwell. Here the question is related to the phenomena, that is interference. Interference experiment performed by whom? That is the question. See here, option A tells that Isaac Newton. Here Newton, he just made some experiment related to the corpuscular theory. Corpuscular theory. So Isaac Newton is wrong answer. Option B, Christian Huygens. This Huygens actually gave the wave theory. So this is also does not match. And option D tells that James Clerk Maxwell. This Maxwell gives about the electromagnetic theory. Electromagnetic theory. So option D is also wrong. The correct option is option C, Thomas Young. See, look at this image. This is the image of Thomas Young. He is the very famous scientist who discovered the interference experiment. We called it as Young's double slit experiment. This related to interference pattern. So the correct option is option C, Thomas Young. Thank you. Hello everyone. Welcome to Sankalp Learning Solution. Let us see question number 4. If a source emits waves uniformly in all directions, the wavefronts close to the source are option A, plane, option B, cylindrical, option C, spherical, and option D, parabolic. Look at this image. Here is source. This S is our source which emits waves. These waves are uniformly distributed in all directions. The wavefront which is close to this surface is means it wavefronts produces in which type of shape means plane, cylindrical, spherical or parabolic. That is the question. As we know, light travels at the same speed in all directions. So it forming concentric spheres of equal phase. Here also this is our source which emits some waves. It is uniformly distributed in all directions like this. These all are the wavefronts. So the wavefront which is close to this source is in the form of concentric spheres. So the correct option is option C, spherical. Option C is the correct answer. Thank you. Hello everyone. Welcome to Sankalp Learning Solution. Let us see question number 5. According to Huygens principle, the new position of a wavefront at a later time t is obtained by drawing a common tangent or envelope to the Option A, rays of light. Option B, secondary wavelets that having spheres of radius v into t. Option C, lines of constant amplitude. And option D, lines normal to the incident wavefront. Observe this image. This question is related to Huygens principle. According to this Huygens principle, every point on a primary wavefront, it acts as a source of secondary disturbances. That is called wavelets. This is the definition of Huygens principle. Every point on a primary wavefront act as a wavelets. See, wavefront at a time t. Initially, this wavefront at a time t, it is in plane wavefront. So, it produces secondary wavelets. This is the image of secondary wavelet. Every point on the wavefront acts as a source of secondary wavelets after time t here. So, after this, new wavefront is generated later time t. This is the image. This image shows the new wavefront at a later time t. It is common tangent or envelope. So, here at a time t, secondary wavelet is generated and it is in spheres of radius v into t. Hence, the correct option is option B, secondary wavelets, spheres of radius v into t. This is the correct answer. Thank you. Hello everyone, welcome to Sankalp Learning Solution. Let us see question number 6. When light travels from a rarer to a denser medium, which physical property of the light wave remains invariant? Option A, speed. Option B, wavelength. Option C, frequency. And option D, amplitude. The question is, when light travels from rarer to denser medium, out of these four physical properties, which physical property remains invariant? Invariant means it does not change. Okay. Look at this image. This is the image which represents the light travel from rarer to a denser medium. As we know, what about when this light travel from rarer to denser, it gets changed its direction and bending towards the normal. Okay. So here, it bending towards normal represents there must be some variant in speed. So option A is wrong. Here speed is not a invariant physical property. Here speed must be varied. So option A wrong. Option B tells about wavelength. Wavelength is also here variant, or this is not invariant property. Wavelength get changes here. So wavelength answer is also wrong. Option D tells about amplitude. Amplitude is also not invariant here. Here amplitude is also changes. This is also variant physical property. So the correct option is option C, that is frequency. Frequency is the invariant physical property of light here. Why? Because this Frequency, generally determined by source of light. This is determined by source of light. Frequency mainly depends upon the source of light. It does not change when this light enters a new medium. So it does not depend on the medium. It depends on the source of light. So here frequency is the invariant physical property of the light travel from rarer to denser medium. Hence option C is the correct answer. Thank you. Hello everyone. Welcome to Sankalp Learning Solution. Let us see question number 7. In the geometrical construction of reflection using Huygens principle, the law of reflection I is equal to R is derived from the observation that two specific triangles in the construction are option A isosceles, option B right angled, option C congruent, and option D similar. Look at this image. Here, according to the construction of reflection using Huygens principle, the law of reflection I is equal to R means angle of incidence I is equal to angle of reflection R here. Here, which specific construction or which type of construction matches here? We can observe one thing here. When this I, incident ray, I is equal to R, here two triangles formed here. So this is one triangle and this is another triangle. We have to find out which property matches here. Option A tells about isosceles. Okay, we will just observe what are the uh, conditions which matches here. First of all, these two triangles are equal, means both the triangles having equal sides. So first most thing is equal sides. This is the first condition which obeys here. And second one, here I is equal to R means it forms right angles here, both sides. Here and here, right angles formed. So, right angles. And then one more condition obey here, that is both these two triangles having common hypotenuse. Common hypotenuse. So these three conditions obey here. Hence option A is wrong. Option B is also wrong. Not only right angles are equal here. So option D is also wrong. Here all these three conditions are comes under congruent triangles. So option C is the correct answer. From the observation, the two specific triangles in the constructions are congruent triangles. So option C is the correct answer. Thank you. Hello everyone, welcome to Sankalp Learning Solution. Let us see question number 8. When the phase difference between two vibrating sources changes rapidly with time, the sources are said to be option A monochromatic, option B coherent, option C polarized, option D incoherent sources. Just look at this image. Here the question is related to phase difference. When the phase difference between two vibrating sources, here we consider two sources, phase difference between these two sources changes rapidly means phase difference is not constant here. Changes means not constant. So that type of sources are said to be what? Option A tells about monochromatic. Monochromatic means light sources emit waves of a single specific wavelength or frequency. Single specific wavelength or frequency, that is called monochromatic light. So here phase difference is not changes rapidly. Option A is wrong. Option B tells that it is coherent. We know that what is coherent and what is incoherent sources. Coherent sources is nothing but they maintain constant phase difference. Constant phase difference. That sources is called coherent. But in this question, they ask about here the phase difference changes rapidly with the time, means phase difference is not constant. So option B is wrong. Option C tells that polarized. Polarized is nothing but orientation of oscillations of waves. Orientation of oscillations of waves, that is called polarized. So this is also not matched with our question. So the correct option is option D, incoherent. Incoherent sources are nothing but the sources which changes this phase difference changes rapidly with time, means sources that does not have a constant phase difference, those are called incoherent sources. So option D, incoherent, is the correct answer. Thank you. Hello everyone, welcome to Sankalp Learning Solution. Let us see question number 9. In Young's double slit experiment, if I naught is the intensity produced by each source, the maximum intensity obtained in the interference pattern is option A I naught, option B 2 I naught, option C 4 I naught, and option D I naught by 2. See, this is the experimental setup of Young's double slit experiment. Here we consider two slits S1 and S2 having the difference small d. This is the coherent light source S. Here, the given thing is if I naught is the intensity produced by each sources. Each sources means source S1 and source S2 having same intensity, that is I naught. So let us take intensity of source S1 is I1 and intensity of source S2 is I2. Resultant intensity of two coherent sources formula. Resultant intensity of two coherent sources. Formula is I is equal to I1 plus I2 plus 2 square root I1 into I2 cos pi. And this is the formula of resultant intensity of two coherent sources. Now, given in the question, that is I0, sorry, I1 and I2 both are equal to I0. This is the given thing. So I0 is the intensity produced by each source. I1 and I2 is equal to I0. Then one more thing is given, maximum intensity. So due to the condition of maximum intensity, when the intensity is maximum is nothing but cos pi is equal to 1. This is the condition for maximum intensity. Now substitute all these things in this main expression. I is equal to I1 plus I2 is nothing but I0 plus 2 square root. In the place of I1 into I2, I0 into I0 comes. Cos pi value is 1. So I is equal to I0 plus I0, it becomes 2I0 plus 2 square root I0 into I0 is square root I0 square. So square root I0 square becomes finally I0 here into 1. So the reason is square root I0 square is I0 only. Now I is equal to 2I0 plus 2I0, we get 4I0. So the resultant intensity of two coherent sources is 4I0. Hence the correct option is option C, 4I0. Thank you. Hello everyone. Welcome to Sankalp Learning Solution. Let us see question number 10. In the wave picture of light, the intensity of light is primarily determined by option A, the frequency of the wave, option B, the square of the amplitude of wave, option C, the speed of the wave, and option D, the wavelength of the wave. In wave picture of light means nothing but according to wave theory, intensity of light is primarily determined by what? According to wave theory, intensity of light is directly proportional to square of the amplitude. This is the standard statement of wave theory. Intensity is always directly proportional to square of the amplitude. So Here the correct option is option B, the square of the amplitude of the wave. This does not directly or primarily determined by frequency of wave, speed of wave and also wavelength of wave. These all are wrong. Intensity is primarily determined by the square of the amplitude of the wave. Hence the correct option is option B, the square of amplitude of wave. Thank you. Hello everyone, welcome to Sankalp Learning Solution. Let us see question number 11. Diffraction effects are generally not noticeable in everyday life when viewing shadows because option A, light waves are longitudinal. Option B, the amplitude of light waves is too small. Option C, the wavelength of visible light is extremely small. And option D, light travels too fast. Here the question is why we can't see the or we cannot noticeable in everyday life of diffraction phenomena when viewing shadows. That is the question. Here option A tells that light waves are longitudinal. This is wrong. First of all, these light waves are not a longitudinal waves. These all are transverse waves. Light wave is transverse wave. So option A is wrong. Option B tells that the amplitude of light waves is too small. This option is also wrong because this amplitude relates to the brightness, not dictate the physical bending of wave. The question is related to diffraction. As we know, what about the definition of diffraction? Diffraction is nothing but bending of light on the obstacle or spread out of light on the obstacle. That is called diffraction. This amplitude of light wave is too small is not correct answer here because amplitude of light, it do not dictate the physical bending of wave. It tells about the brightness. So option B is also wrong. Option D, light travels too fast. This is also wrong. Why? Because this light travels too fast. Here, the sentence is related to speed. This speed does not prevent the diffraction. Speed does not prevent diffraction. So this is also wrong. Then diffraction effects are generally not noticeable in everyday life when viewing shadows. Why? Because light travels in straight lines. We know that light always travels in a straight line and creates sharp shadows instead of bending around them. Light always travels in a straight line and creates a sharp shadows instead of bending around them because objects are so large relative to wavelength. Here objects are so large relative to wavelength. Hence, we can't notice the diffraction pattern in our everyday life when viewing shadows. So, the correct option is option C. The wavelength of visible light is extremely small as compared to object wavelength. Because these objects are so large relative to wavelength, so the wavelength of visible light is extremely small. Hence, we cannot notice the diffraction phenomena in our everyday life when viewing shadows. So, C is the correct option. Thank you. Hello everyone, welcome to Sankalp Learning Solution. Let us see question number 12. The limits of the ability of microscopes and telescopes to distinguish very close objects are ultimately set by the phenomenon of option A reflection, B refraction, C polarization and D diffraction. The question is the limits of ability of microscopes and telescopes. These microscope and telescopes are optical instruments. These two are the optical instruments. So, limitation of ability of these optical instruments to distinguish very close objects are related to which phenomena? That is the question. Look at this image. Let us imagine it is an optical instrument, whether it may be microscope or telescope. So, this resolution of optical instrument limited by the phenomenon of diffraction. This is limited by diffraction phenomena of light. Why? Because we know that limited is nothing but drawback. Okay. Here, when light waves pass through aperture of a lens. See, this instrument consists of lens. When light waves pass through the aperture of a lens of this instrument, they spread out and create a blurred pattern. They spread out and create a blurred pattern, not a clear pattern. If two objects are so close that their diffraction patterns overlap, so due to this overlap, significantly they cannot be seen as separate entities. So that is the limitation of the diffraction phenomena of this optical instruments. Hence the correct option is option D, diffraction. Means this optical instruments are fails to produce the clear image. Hence option D is the correct answer. Thank you. Hello everyone, welcome to Sankalp Learning Solution. Let us see question number 13. The intensity distribution in a single slit diffraction pattern includes zero intensity, that is the minima condition, occurring at angles theta such that sin theta is nearly equal to theta. So which equation is the correct answer? Option A, n plus half into lambda by A. Option B, n lambda by A. Option C, lambda by 2A. And option D, lambda by A only. So the question is related to intensity distribution in a single slit diffraction. As we know, diffraction pattern takes place in single slit and double slit also. Single slit diffraction pattern, which includes zero intensity minima, we have to find out the expression. Only the given thing is sin theta is very small here, we can take it as theta. So let us consider condition for nth minimum in a single slit diffraction. Condition for the nth minimum in single slit diffraction. So the expression tells about the condition for the nth minimum in a single slit is formula A sin theta is equal to n lambda. This is the standard expression for nth minimum in a single slit diffraction. Here A indicate the slit width. A is slit width. This is slit width and theta is the angle of diffraction. Angle of diffraction. And then n is an integer. Let us take it as plus or minus 1, plus or minus 2 and so on. And lambda indicates the wavelength of light. Wavelength of light. So this is the standard expression. A sin theta is equal to n lambda. The given thing is sin theta is very small. So we consider it as theta only. The expression becomes theta is equal to n lambda by A. In this expression, sin theta is nearly equal to theta. Substitute those things. This expression becomes A theta is equal to n lambda. We want theta here. Theta is equal to n lambda by A. So the correct option is option B, n lambda divided by A. Thank you. Hello everyone, welcome to Sankalp Learning Solution. Let us see question number 14. When unpolarized light is passed through a Polaroid, the transmitted light becomes linearly polarized with the electric vector oscillating along a direction known as option A, absorption axis, option B, plane of incidence, option C, pass axis, and option D, Brewster axis. Look at this image. This is our unpolarized light. This unpolarized light is passed through this Polaroid. Here, unpolarized light going to pass through this Polaroid. When this unpolarized light pass through this Polaroid blocks electric field components oscillating in all directions except for one specific axis. This polaroid blocks the electric field component oscillating in all directions except for one specific axis. So this is the actual concept takes place here. An unpolarized light passes through this polaroid. This polaroid actually it blocks electric field components which are oscillating in all direction. Instead of oscillating in all direction, it make possible it oscillate only in a specific axis. So here the correct option is that oscillating along a direction is known as path axis. So the correct option is option C, path axis. Thank you. Hello everyone, welcome to Sankalp Learning Solution. Let us see question number 15. If the speed of light in vacuum is c is equal to 3.0 into 10 raised to 8 meter per second and speed of light in water is Pw is equal to 2.25 into 10 raised to 8 meter per second, the refractive index of water is approximately what? We have to calculate the refractive index of water, that is eta W is equal to, as we know what is the formula of refractive index, n is equal to c by v is the standard formula for refractive index. Here c is nothing but speed of light in vacuum and v is the speed of light in medium. Here the given thing c value is given, that is 3.0 into 10 raised to 8 meter per second and v is nothing but speed of light in medium. Which medium? Here they consider it as water medium. So Vw is equal to 2.25 into 10 raised to 8 meter per second. Now substitute C is 3.0 into 10 raised to 8 divided by V is 2.25 into 10 raised to 8. 10 raised to 8, 10 raised to 8 get cancels out. 3.0 divided by 2.5, we get 1.33. So refractive index of water is approximately 1.33. Hence, the correct option is option B, 1.33. Thank you. Hello everyone, welcome to Sankalp Learning Solution. Let us see question number 16. When a plane wavefront is incident on a concave mirror, the reflected wavefront converges to the focal point F. This reflected wavefront is option A plane, option B diverging spherical, option C converging spherical, and option D cylindrical. Look at this image. When a wavefront is incident on a concave mirror, here wavefront which is going to incident on a concave mirror. After reflection, this wavefront converges at a single point. That point is called focal point F. This reflected wavefront is in the shape of what? That is the question. Here, incident plane, that is wavefront. This is our incident plane which is going to incident on this concave mirror. As we know, concave mirror always converges all light rays at a single point. That point is called focal point F. Here also, this incident plane wavefront hits the surface of this concave mirror and get reflected at a point F, that is considered as focal point. So in this point, this reflected wavefronts are like this. They all are in a spherical shape. This indicates the reflected spherical wavefront. So this is not in plane form, not diverging concept happens here. Here only converging takes place. So option B is also wrong. Option D, after reflection, the shape is not a cylindrical. So option D is also wrong. Here the correct option is option C, converging spherical. First of all, this incident plane wavefront, after this reflection, they all get converged at a single point. That point is called focal point F, and after that they all are in the shape of spherical wavefronts. So option C is the correct answer. Thank you. Hello everyone, welcome to Sankalp Learning Solution. Let us see question number 17. The distance between the central bright fringe n is equal to 0 and the fourth bright fringe n is equal to 4 in YDSE is measured if the slit separation is D is equal to 0.28 millimeter and the screen distance D is 1.4 meter and the distance measured is 1.2 centimeter. The wavelength lambda is approximately option A 300 nanometer, option B 600 nanometer, option C 450 nanometer and option D 750 nanometer. Look at this image. This question is related to Young's double slit experiment. YDSE means Young's double slit experiment. Here we consider two fringes n is equal to 0 to n is equal to 4. The given things, capital D is given, small d is given, and this 1.2 centimeter, it indicates the Young's fourth fringe value. Y4 is equal to 1.2 centimeter. We have to convert it into meters and finally calculate the lambda. We'll see how to calculate this one. First of all, here we consider or we use the formula of Young's double slit experiment in nth fringe. Yn is equal to n lambda capital D by D. This is the standard expression for Young's double slit experiment for find out the nth fringe. Here the given thing is order of fringe is given. Order of fringe, that is nothing but n equal to 0 to n is equal to 4. We require what about y4? So y4 is already given, that is 1.2 centimeter. Convert it into meters, that is 1.2 into 10 raised to minus 2 meter. Then one more thing is given, d value, that is 0.28 millimeter. D is nothing but distance between two slits S1 and S2. that is given 0.28 millimeter. We have to convert it into meters. 0.28 into 10 raised to minus 3 meter. Milli is nothing but 10 raised to minus 3. Centi is nothing but 10 raised to minus 2. Then one more thing, capital D value is given. That is 1.4 meter. Now rearrange this expression because we want lambda value here. So the expression becomes lambda is equal to yn divided by n into capital D. Here yn is nothing but y4. Substitute those values here. So yn is nothing but y4 here. That is 1.2 into 10 raised to minus 2 into small d value is 0.28 into 10 raised to minus 3 divided by n is 4 and capital D is 1.4. Now simplify the expression. We get lambda is equal to 0. Lambda is equal to 0.336 into 10 raised to minus 2. 10 raised to minus 3 is there. It becomes 10 raised to minus 5 divided by 5.6. 4 into 1.4 is 5.6. We get lambda is equal to 0.06 into 10 raised to minus 5. But the options are not in 10 raised to minus 5. So the options are in nanometer. Nano is nothing but 10 raised to minus 9. We have to write it in 10 raised to minus 9 form, that is 600 into 10 raised to minus 9 is nothing but 600 nanometer. Hence the correct option is option B. 600 nanometer is the wavelength of the fringe. Thank you. Hello everyone. Welcome to Sankalp Learning Solution. Let us see question number 18. Two light waves of equal intensity I naught interfere. The intensity I at a point where the phase difference is pi is equal to pi radians is. Option A I naught, option B 2 I naught, option C 4 I naught and option D 0. Two light waves of equal intensity is given, that is I naught. So two light waves equal intensity is nothing but I1 is equal to I2. Both are same, that is I0. In the place of I1 and I2 we have to substitute I0 here, and again this is given thing, and one more thing is given, that is we have to substitute pi value is pi. This pi is nothing but 360 degree. So the formula is resultant intensity of this expression I is equal to I1 plus I2 plus 2 square root I1 into I2 cos pi. This is the expression. Now we have to substitute in the place of I1 and I2, that is I0. Expression becomes I is equal to I0 plus I0 plus 2 square root I0 into I0. In the place of pi we have to take cos pi. What is the value of cos pi? Cos pi is nothing but cos 180. Sorry, here pi is 180 degree. So cos 180 is minus 1. Cos 180 minus 1. In the place of cos pi, substitute minus 1. We get I is equal to I naught plus I naught becomes 2 I naught plus 2 square root I naught into I naught becomes square root I naught square. So the square root get cancels out, remaining I naught. 2 I naught into cos pi value is minus 1. Now the expression becomes I is equal to 2 I naught minus 2 I naught. It gives 0. So the correct option is option D, 0. Thank you. Hello everyone. Welcome to Sankalp Learning Solution. Let us see question number 19. If A is the width of a single slit, the angular position theta of the first secondary minimum is given by option A, theta is equal to A by lambda. Option B, theta is equal to 2 lambda by A. Option C, theta is equal to lambda by A. Option D, theta is equal to 3 lambda by 2A. If A is the width of a single slit, the angular position theta for first secondary minimum. First secondary minimum is nothing but n is equal to 1. This is the given thing. Then single slit diffraction formula, single slit diffraction formula, A sin theta is equal to n lambda. This is the formula. A sin theta is equal to n lambda. Here lambda is the wavelength of light and n is the integers 1, 2, 3 and so on. Here n value is given, that is 1, because already it is mentioned in the question first secondary minimum is nothing but n is equal to 1. Then substitute the value A sin theta is equal to, in the place of n, 1 here, so it becomes lambda. Then we know that theta is very small here. Theta is very small because this is minimum condition. So let us take sin theta is nearly equal to theta. Here we consider sin theta is nearly equal to theta. In the place of sin theta, we have to write A theta is equal to lambda. Theta is equal to lambda by A. Hence, the correct option is option C, theta is equal to lambda by A. Thank you. Hello everyone. Welcome to Sankalp Learning Solution. Let us see question number 20. If the wavelength lambda and slit width A are doubled in a single slit diffraction experiment, the angular width of the central maximum is option A remains same, option B is halved, option C is doubled, option D is quadrupled. So here we have to calculate and then decide which option is correct. if the wavelength lambda and slit width A are doubled. If suppose A and lambda are doubled, then what about the angular width of the central maximum? We'll see angular width of central maximum value for single slit diffraction. We have to consider the formula of angular width of central maximum for single slit diffraction experiment. Formula is theta is equal to 2 lambda by A. This is the formula. Theta is equal to 2 lambda by A. Now the given thing is this lambda and A are get doubled. So this, let us consider new value of lambda and A are lambda dash and A dash. So lambda dash is 2 lambda and A dash is 2A. These two are the given things in the question. Then substitute this theta becomes theta dash. Theta dash is equal to 2. In the place of lambda, 2 lambda comes divided by, in the place of A, new A, that is 2A comes, 2 get cancels out. So we get theta dash is equal to 2 lambda by A. 2 lambda by A is nothing but it is theta value. So it is theta. Hence, we can conclude that theta dash is equal to theta. Both are same. When this lambda and A are get doubled, still the value remains the same. Hence, the correct option is option A, remains the same. Thank you. Hello everyone, welcome to Sankalp Learning Solution. Let us see question number 21. This is the statement type question. Two statements are given. We have to find out whether both the statements are true or false and what. Okay. Statement 1. Wavefronts obtained from light emitted by a point source in an isotropic medium are always spherical. Statement 2. Speed of light in isotropic medium is constant. Let us check whether these statements are true or false. Statement 1 tells that wavefronts obtained from light emitted by a point source in an isotropic medium are always spherical. Yes, this statement is true. Why? Because as we know, light travels at the same speed in every direction. Hence, it reaching the surface of a sphere at the same time. So, wavefronts obtained from light emitted by a point source in an isotropic medium are always spherical. Statement 2. Speed of light in isotropic medium is constant. Yes, this statement is also true. Or we can say that this statement is true. Speed of light in isotropic medium is constant. This statement is true because this statement tells that physical reason why the wavefront maintains a spherical shape as it expands. This statement clearly explains the physical reason why the wavefront maintains a spherical shape. So, this statement is also true. And also, statement 2, which correctly explains the statement 1. Hence, the correct option is option A. Both statements are true, and statement 2 is the correct explanation for statement 1. Thank you. Hello everyone. Welcome to Sankalp Learning Solution. Let us see question number 22. Statement 1. Interference is not observed if the two coherent slits are broad. Statement 2. A broad source is equivalent to many narrow slit sources. So let us check statement first. Interference is not observed if the two coherent slits are broad. ಎರಡು ಕೋಹರೆಂಟ್ ಸ್ಲಿಟ್ ಬ್ರಾಡ್ ಇದ್ರೆ ವಿ ಕೆನಾಟ್ ಅಬ್ಸರ್ವ್ ದ ಇಂಟರ್ಫರೆನ್ಸ್. ದಟ್ ಇಸ್ ದ ಮೀನಿಂಗ್ ಆಫ್ ದಿಸ್ ಸ್ಟೇಟ್ಮೆಂಟ್. ಆಕ್ಚುಲಿ ದಿಸ್ ಸ್ಟೇಟ್ಮೆಂಟ್ ಈಸ್ ಟ್ರೂ. This is true statement. Why? Because for clear interference fringes to be seen, the source must be narrow. The source must be narrow, then we can see the clear interference fringes. Otherwise, we cannot see the clear interference fringes. If suppose the slits are broad, that interference is not clear observed. We cannot observe the interference clearly. So, the statement is true. Statement 2, a broad source is equivalent to many narrow slit sources. This is also true, because that one broad source is the equivalent to many narrow slit sources. So, statement 2 is also true. And also, the statement 2 correctly explains the statement 1. If suppose broad source is equivalent to many narrow slit sources, here we consider broad source, we cannot observe the clear interference. So statement 2 correctly explains the statement 1. Here the correct option is option A. Both statement 1 and 2 are true, and statement 2 is the correct explanation for statement 1. Thank you. Hello everyone. Welcome to Sankalp Learning Solution. Let us see question number 23. Statement 1. When a thin transparent sheet is placed in front of both the slits of Young's experiment, the fringe width will remain same. Statement 2. In Young's experiment, the fringe width is directly proportional to wavelength of the source. Let us check the statements. Statement 1. This is related to Young's double slit experiment. In this Young's double slit experiment, thin transparent sheet is placed in front of two slits. As we know, in Young's double slit experiment, we use two slits. One is S1 and S2. Here, one thin transparent sheet is placed in between those two slits S1 and S2. Then the fringe width will remain same. This statement is true. The statement is true. Why? Because path difference between two waves remains unchanged here. Path difference between two waves unchanged here. Hence, fringe width will also remain same. We have to remember one thing here. When this fringe width remains or when this fringe width get changed, when path difference between two waves are changed, that time only fringe width is also changes. Otherwise, fringe width remains same. Here, when we place thin transparent sheet in front of both slits, still we get that same fringe width because path difference between these two waves get unchanged here. That's why fringe width will also remains same. So this statement is true. Statement 2. In Young's experiment, the fringe width is directly proportional to wavelength of the source. Here we require the formula. Formula of fringe width in Young's experiment is fringe width is denoted as beta. Beta is equal to lambda capital D by D. This is the expression of fringe width in a Young's experiment. According to this expression, fringe width is directly proportional to wavelength lambda here. So statement 2 is also true. Statement 1 is also true and statement 2 is also true. But only the one thing is this statement 2 not correctly explains the statement 1 because there is no relation in these two experiments, in these two statements. That's why both the statements are true, but 2 is not the correct explanation of 1. Hence, the correct option is option B. Both statements are true, but 2 is not the correct explanation of 1. Thank you. Hello everyone, welcome to Sankalp Learning Solution. Let us see question number 24. To observe sustained interference pattern on a screen placed at a suitable distance in a Young's double slit experiment, which of the following condition or conditions is or are necessary? 1. Sources of light should be coherent. 2. Sources of light should be narrow. 3. Sources of light should be very close. We have to find out to observe sustained interference pattern on a screen related to Young's double slit experiment. What are the conditions are necessary, or what is the condition necessary? We have to find out. Let us check the statements one by one. Sources of light should be coherent. This is necessary or not? In Young's double slit experiment, to obtain interference pattern on a screen for a suitable distance, the source of light should be coherent is very, very important. So, this statement is necessary. Why? Because coherent is nothing but they maintain a constant phase difference over time. Coherent means maintain constant phase difference. So this condition is very, very necessary to obtain the sustainable interference in Young's double slit experiment. So first statement required. Second one, sources of light should be narrow. Yes, this is also necessary. Why? Because this light source should be narrow. It acts as a point source. Acts as point source and produces a significant diffraction. So sources of light should be narrow is also necessary. Statement 3, sources of light should be very close. This is also necessary thing. Why? Because distance must be very small. Very close means distance must be very small. Why this distance must be very small? Why the statement becomes necessary? Means once this distance must be very small or sources of light should be very close, it helps to ensure a larger fringe width, or it gives the very large fringe width. So this is also one of the necessary condition. Hence 1, 2 and 3 all are necessary conditions here. So option D is the correct answer. All 1, 2 and 3 are necessary. Thank you. Hello everyone, welcome to Sankalp Learning Solution. Let us see question number 25. A plane polarized light beam of intensity I naught is incident on an analyzer. The angle theta between the pass axis and the polarization plane required to transmit an intensity of I naught by 4 is option A 30 degree, option B 45 degree, option C 60 degree and option D 90 degree. We have to calculate the theta value here. So a plane polarized light beam of intensity I naught is incident on an analyzer here. We have to calculate the angle theta between the pass axis and polarization plane. Only the given thing is intensity I is equal to I naught by 4. This is the given thing. I is equal to I naught by 4. So, here we use Malu's law using Malus law that tells that intensity I is equal to I naught cos square theta. I is equal to I naught cos square theta. In the place of I, we have to substitute I naught by 4. This is given in the question. So expression becomes I naught by 4 is equal to I naught cos square theta. I naught get cancels out. So 1 by 4 is equal to cos square theta remains. Then remove this square. So cos theta is equal to square root 1 by 4. Or make square root on both sides. So square root cos square theta becomes cos theta and 1 by 4 becomes square root 1 by 4. So cos theta is equal to square root 1 by 4 is nothing but 1 by 2. We require theta. So it becomes cos inverse 1 by 2. Theta is equal to cos inverse of 1 by 2. As we know, cos inverse of 1 by 2 is nothing but it is 60 degree. So theta is 60 degree. The correct option is option C, 60 degree. Thank you. Hello everyone. Welcome to Sankalp Learning Solution. Let us see question number 26. The total time taken for light to travel from a point on the object to the corresponding point on the image is the same measured along any ray. This principle is consistent with Huygens construction because option A, wavelength must remain constant. Option B, rays are perpendicular to wavefronts and the time of travel along all rays is equal. Option C, amplitude must be maximized. And option D, refractive index varies inversely with the speed. Here the question is, total time taken for light which is traveling from a point to, or it is traveling from object to a point image. This principle is consistent with the Huygens construction because that is the question. Option A tells that wavelength must remain constant. Here, this wavelength not remains constant because this wavelength changes when moving different media. It changes when moving different media. So option A is wrong. Option C tells that amplitude must be maximized. This this amplitude optimization, it does not dictate the travel time. Amplitude optimization, it does it does not dictate travel time. So this is also not correct. And option D, refractive index varies inversely with the speed. It does not explain wavefront. This refractive index term does not explain wavefronts. Because this Huygens construction or principle related to wavefront, so this refractive index varies inversely with the speed. It does not explain wavefront term. So option D is also wrong. Here the correct option is option B. Rays are perpendicular to wavefronts here, and the time of traveling along all rays are equal. Hence option B is correct. Thank you. Hello everyone, welcome to Sankalp Learning Solution. Let us see question number 27. In the context of Young's experiment, the function of the single pinhole S illuminated by a bright source, so illuminate by a bright source is to ensure that the two slits S1 and S2 behave as option A, two independent sources, option B, two incoherent sources, option C, two coherent sources, and option D, two diffraction centers. Look at this image. This is the image related to Young's double slit experiment. The function of a pinhole, this SC is considered as single pinhole here, and then we consider two sources S1 and S2. We have to ensure that these two slits S1 and S2 behaves as what? Here we have to remember one thing. Coherent sources are very important to produce the clear interference pattern in Young's double slit experiment. So coherent is nothing but interference requires a constant phase difference between the waves. Here, single pinhole S. This creates a single wavefront. The single pinhole creates single wavefront. So, single pinhole creates single wavefronts. This slits S1 and S2 maintain a constant phase. They act as coherent light sources. These S1 and S2 act as a coherent light sources and maintain a constant phase. So, here we require two coherent sources. Hence, the correct option is C, two coherent sources. Here, independent sources cannot maintain coherency. So, not two independent sources, not two incoherent sources, not two diffraction centers. We require two coherent sources to maintain a coherent and constant phase difference to produce clear interference patterns. So the correct option is option C. Thank you. Hello everyone. Welcome to Sankalp Learning Solution. Let us see question number 28. The definition of a plane polarized wave for a vibrating string propagating along the x direction implies that the string option A has randomly changing vibration plane, option B remains confined to a single plane, that is the xy plane, option C how has its displacement parallel to the direction of propagation, and option D requires a medium for propagation. Question is the definition of a plane polarized. This is important. This question related to the definition of plane polarized wave for a vibrating string. The question tells that this vibrating string which is propagating along x direction, it implies that what? Option A tells that has randomly changing vibration plane. This randomly changing vibration plane related to unpolarized wave. Unpolarized wave. So option A is wrong. Why? Because this statement is related to plane polarized wave, not unpolarized wave. Option C tells that has its displacement parallel to the direction of propagation. This is also wrong. Why? Because this statement describes a longitudinal wave like a sound wave. It explains longitudinal wave like sound waves. So option C is also wrong. This statement does not explain about a transverse wave. We require transfer wave definition here. So option C is also wrong. Option D requires a medium for propagation. This is wrong. Yes, that require a medium for their propagation, but this is the general characteristic. It not define the polarization definition. This is only general characteristic. So option D is also wrong. Here option B is the correct answer. Remains confined to a single plane, that is XY plane. Why the statement B is correct? Why? Because the wave is propagating along the x direction which is mentioned in the question. Already this wave is propagating in x direction. So the vibration of the string element must stay confined to that specific plane only. So that is xy plane. Hence option B is correct. Thank you. Hello everyone. Welcome to Sankalp Learning Solution. Let us see question number 29. Which statement correctly describes the behavior of a plane wavefront incident on a thin convex lens? Option A, the ray traveling near the edge is delayed the most. Option B, the ray traveling through the center is delayed the most because it transverses the thickness portion of the lens. Option C, all points on the wavefront are delayed equally. And option D, the resulting spherical wavefront diverges due to energy loss. Look at this image. Here, four statements are given. Which statement correctly describes the behavior of plane wavefront when it is incident on a thin convex lens? Here, plane wavefront which is going to incident on a thin convex lens. As we know, convex lens, it is thick at its center. Thick at its center and thin at its edges. And thin at its edges when this incident plane wavefront come and hit the surface of this thin convex lens. Here you have to remember one thing: light travels slower in a glass lens than in air. Light travels slower in a glass lens as compared to light travel in air. Air ಗೆ compare ಮಾಡಿದ್ರೆ light is always travel slow in a glass lens. Here the light is incident on this glass lens, that is thin convex lens. This thin convex lens is always thick at its center and thin at its edges. So this incident plane wavefront get delayed based on the thickness. This is generally speed of this light travel through this glass. It is based on the thickness, or it is based on the thickness of the glass lens. So here the correct, when this incident plane wavefront start get incident on the surface of the thin convex lens, after it get passes through the center of this convex lens, center is thick, so it get delayed. Hence the correct option is option B. The ray traveling through the center is delayed the most because it transfers the thickness portion of the lens. So this is the main reason. Hence the correct option is option B. Thank you. Hello everyone. Welcome to Sankalp Learning Solution. Let us see question number 30. The speed of light in glass is depend on the color or wavelength of light. If red light has a longer wavelength than violet light, which color transverse or which color travels slower in a glass prism? Option A, both travel at the same speed. Option B, red travels slower. Option C, violet travels slower. And option D, speed is independent of color. See here, as we studied already, how the light passes through the prism. Okay, here dispersion takes place. It gets split into 7 colors, and all those 7 colors are bending differently. The question is, if red light has longer wavelength as compared to violet light, which color travels slower in a glass prism? Compare with the red and violet. Okay. Here, as we know, refractive index of glass N is equal to C by V. Here, refractive index is always inversely proportional to speed. Here, high refractive index means refractive index and speed are inversely proportional. High refractive index means speed is low. So lower speed. So here the correct option is violet travels slower because refractive index is high here, and also the wavelength of the violet is small as compared to red light. So violet travels slower. Hence option C is the correct answer. Thank you. Hello everyone, welcome to Sankalp Learning Solution. Let us see question number 31. When interference or diffraction occurs, light energy is redistributed This mechanism ensures that option A, total energy is lost due to dark fringes. Option B, energy gained in bright fringes equals energy lost in dark fringes, maintaining conservation of energy. Option C, energy is gained due to constructive superposition. And option D, the amplitude of the wave decreases over time. The question is, when interference or diffraction occurs, light energy is redistributed. This mechanism ensures that means in the phenomenon of interference or diffraction, light energy is not created or destroyed. Instead of that, it is redistributed from the regions of destructive interference to constructive interference. This purely tells about the mechanism of law of conservation of energy. Means energy gained in bright fringes is equal to energy lost in the dark fringes. It tells about the conservation of energy. Here no energy get lost, energy get balanced due to the redistribution. Hence the correct option is option B. Energy gained in bright fringe is equal to energy lost in dark fringe, maintaining the conservation of energy. Thank you. Hello everyone. Welcome to Sankalp Learning Solution. Let us see question number 32. When light is incident on a surface separating two media, the reflected light has same frequency as the incident light. This is explained by modeling the atomic constituents of matter as option A, stationary particles, option B, oscillators taking up the incident frequency, option C, sources of spontaneous emission, and option D, perfect reflectors. Look at this image. When light is incident on a surface separating two media, this is the surface which is separating from medium 1 and medium 2. When light get incident on this one medium to another, it exert an oscillating electric field. It exert an oscillating electric field. After this, each oscillating electron acts as a source of secondary waves. Here, when the light is incident on this surface, this exerts an oscillating electric fields. So, incident light having frequency F here, it oscillates some electric fields. After this, each oscillating electron, so due to the surface, each oscillating electrons acts as a source of secondary waves. So this also contains the frequency F, which is coming from incident light. So oscillators taking of the incident frequency, that is the correct answer. Hence option B is the correct answer. Oscillators taking up the incident frequency F here. So option B is the correct answer. Thank you. Hello everyone, welcome to Sankalp Learning Solution. Let us see question number 33. The phenomenon of total internal reflection requires that the angle of incidence is greater than the critical angle. When this condition is met, the angle of refraction R is effectively option A 90 degree, option B greater than 90, option C non-existent, and option D 0 degree. The question is related to total internal reflection, TIR. The condition for total internal reflection is angle of incidence must be greater than the critical angle. This is the condition for the total internal reflection. So in this condition, angle of incidence is greater than the critical angle. Total internal reflection takes place. So there is no ray of light get passed through this boundary. So there is no reflection takes place here in the condition of total internal reflection. Hence, when I is greater than IC, total internal reflection takes place. But here, no light passes through the boundary. Hence, there is no angle of refraction takes place. So, the correct option is option C. Angle of refraction R is effectively non-exist here. So, the correct option is option C. Thank you. Hello everyone, welcome to Sankalp Learning Solution. Let us see question number 34. Two wavelengths lambda 1 is equal to 650 nanometer, lambda 2 is equal to 520 nanometer are used in YDSE, means Young's double slit experiment. If d by d is constant, the minimum non-zero order n1 for lambda 1 at which the bright fringes coincide with the bright fringe of lambda 2 order n2 is. So, here again the question is related to Young's double slit experiment. Lambda 1 and lambda 2 are given. Lambda 1 is 650 nanometer and lambda 2 is 520 nanometer. We have to find out n1 and n2 value. n1 and n2 value. After that, here we get n1 value. So, the formula for nth bright fringe in Young's double slit experiment, yn is equal to n lambda d by d. Here, d by d is constant, which is given in the question. So, the expression becomes n1 lambda 1 is equal to n2 lambda 2 because 2 lambda and 2 n values are there. Now substitute lambda 1 and lambda 2 value. Lambda 1 is 650 nanometer and lambda 2 is 520 nanometer. Substitute and find out. The expression becomes n1 by n2 is equal to lambda 2 by lambda 1. So n1 by n2 is equal to lambda 2 is 520 and lambda 1 is 650. 520 divided by 650, we get n1 by n2 is equal to 4 by 5 is nothing but n1 is 4 and n2 is 5. We require only n1 value. Hence, the correct option is option A, n1 is equal to 4. Thank you. Hello everyone, welcome to Sankalp Learning Solution. Let us see question number 35. if linearly polarized light of intensity I0 is incident on a polarizer and the transmitted intensity is I0 by 2, the angle theta between the polarization direction and the path axis is A 0 degree, B 90 degree, C 45 degree and D 60 degree. Here only the given thing is intensity is given, that is I0 by 2. Again we have to use Malus law. According to this expression, intensity I is equal to I0 cos square theta. This is the expression. Here given thing is I is equal to I0 by 2. This is given. I is equal to I0 by 2. So expression becomes, in the place of I, we have to substitute I0 by 2. I0 by 2 is equal to I0 cos square theta. I0 get cancels out. We get 1 by 2 is equal to cos square theta. Then squaring on both sides, cos theta is equal to 1 by square root 2. Theta is equal to cos inverse of 1 by square root 2. So cos inverse 1 by square root 2 is nothing but it is 45 degree. Theta is 45 degree. Hence the correct option is option C, theta is 45 degree. Thank you.